so learning outcome 4 is this big list of wave parameters. So let's say we're going to start with 3, which are defined from a diagram. So what I want to remind you of from last year is how do we draw these wave diagrams? In actual fact, can you make these diagrams, first of all, make them as big as possible. So make sure this diagram fills the width of your page, because it then becomes much easier to label everything. But what you might remember from last year is we started by putting some regular dots on the page just to make sure that the wave you end up drawing is regular. Now I'm working on a totally blank page here. You've at least got lines, which can help you a wee bit, but along those lines you're going to have to put some dots. Okay, so I'm going to start by putting some dashed lines, which could represent the lines in your jotter. This ruler just slides everywhere while I'm doing this. So you don't need to put these really, because you can use the lines in your jotters. And what I would suggest is you maybe, the top of the wave there that I've marked, have that about 3 lines up from the middle, and the bottom about 3 lines down. Okay, and then on this, in a different colour, so I'll use yellow for this. What I'm going to do is mark out using a ruler, and I've got some rulers here if you need to borrow one. I'm going to mark out some regular spaced dots. So I'm going to use every 2 centimetres. So put 1 dot there, put a dot every 2 centimetres along my page. And these are all just kind of guidelines. Okay. I'm working my way along these dots. So I'm going to start in the middle of my diagram. So I'm going to use that middle dot. But then the next dot, what I'm going to do is put another dot directly above that on my top line. And then back to the middle, because this is what waves do. But then put one directly below the 4th dot. Back to the middle, one above the 6th dot, back to the middle, one below the 8th dot, and then back to the middle. Okay, so you see these extra dots now that have appeared. So above dot 2, below dot 4, above dot 6, below dot 8. And now what I've got is the basic shape of the wave, so that when I come now to draw it, right, freehand, I've got something to aim for, which gives me a nice regular pattern to the wave. Does that make sense? So my wave goes up through the first dot. Not very well done, I'm going to try that again. This is awkward on an iPad. Down to the 2nd dot. Down to the bottom for the 4th dot, back up through the 5th, to the top at the 6th, back down through the 7th, to the bottom for the 8th, and back up for the 9th. Now, I do find this much easier to do in a jotter or something like that, but you get the basic idea there. And on that, we're going to start to mark these important points. So this point here is called the crest, or the peak you might occasionally come across. It's called as that. So there is a crest in the first wave as well, but I'm just labelling one of them. And this point here is called the trough, T-R-O-U-G-H. So that's 2 of the things defined that we needed for this learning outcome. The third one I'm going to define in the diagram is wavelength. Anyone remember what we meant by wavelength?
From one crest to the
Yeah, that's probably the most obvious place to do it. So I'm going to put a red arrow from one crest to the next, if my roller would stop slipping around. And the symbol we use for a wavelength is a Greek letter we met last year. It's a Greek letter lambda. Right, if you think about it as a kind of front legs, or did we meet that last year? No, we did. Did we just talk about wavelength? Right, so it's a Greek letter, and I like to kind of think of it, it's a bit like an upside down Y, except it's got a bit of a tail. I think it's easier to think about it as the front legs of a giraffe. Okay, so you've got the front legs, the big long neck, and then the head of the giraffe. But you'll get used to drawing that. And just to clarify that, underneath, so there's the symbol lambda. It stands for wavelength. And the standard unit of wavelength, because it's a length, is simply meters. And it's not the only place I could draw a wavelength. Anyone want to suggest another place which would be that same length in these nice regular waves? Kosha? Yeah, so there's dot 1, 2, 3, 4, 5. Yeah, dot 5. Okay? So you've got to be careful with these ones if you're doing it in the middle, because it's not back to the same position, right? It's back to the same position but moving in the same direction. So I don't stop at dot 3 because at that point the wave's coming down. I go all the way to dot 5 where the wave is going up again. So that is also a wavelength. And I could stick one in at the bottom as well, from trough to trough. There's also a wavelength. Okay. The other things we need to define: frequency. And I don't think we got as far as the units last year. Frequency is measured in hertz, right? The same as a car rental company, if you've ever come across them. It's a German name, but it's abbreviated as HZ. Right? The units are abbreviated as HZ. The symbol for frequency is quite simple, F. But with that, we want to give a definition, right, of what frequency means. Right, wavelength is kind of defined on the diagram, but frequency we haven't. And we talked a wee bit about that the other day. Frequency is the number of waves in 1 second. Okay, so a frequency of 5 hertz means there are 5 waves every second. Oh, and the next one, actually, we can do on the diagram as well. I forgot to do that one in. This is one you met last year. A for amplitude. Anyone want to remind me of what an amplitude is? Yeah, measured from where to where? From the trough to the crest?
Oh, no, from the middle.
From the middle, good. Okay. So just watch. So that was quite often what questions were based on last year. If we told you the distance from the trough to the crest, then you have to half it to get the amplitude. The amplitude is how tall the wave is from its undisturbed position. So if you imagine this was a water wave, right, created by dropping a stone into a pond, if you looked at the level of the water to start with, it would be along that middle line that I've drawn. So that would be the undisturbed position. So an amplitude could also be filled in at various points. So from the middle to the top, or from the bottom to the middle. They're both amplitudes. So V is speed, and it's measured in meters per second. Now, we're going to use slightly different units. You may have used m/s last year, and that's still fine, it's still acceptable. But when you're doing exams, you'll see it written as this way, as ms to the -1. So if you imagine a power, it is a power, so if you imagine it was squared, you'd put a wee 2 kind of up high. Here we put a -1 up high. And that's how we write meters per second. And speed means distance. Oops, let's try that again. Distance travelled per second, or maybe per hour. Okay, and it's called the period of a wave, and it's given the symbol capital T as opposed to a small t, which we use for a general time. And the period is the time taken for one complete wave.